So in this final video, we're going to take a look at two examples of the law of sines where we have an ambiguous case, and there may be more than one triangle that we can generate from the given information. Okay, so we have A is 35 degrees, B is 12, and I'm sorry, A is 12 and B is 16. So let's try to find angle B. So we would say that the sine of 35 degrees divided by 12 is going to be equal to the sine of B divided by 16. We can multiply both sides by 16. So we would get 16 sine of 35 degrees divided by 12 is going to be equal to B. All right? And then we could just go into our calculator. And we have 16 sine of 35 divided by 12, making sure we're in degree mode. And that gives us 0.765. Okay, so that's going to be 0.7, and this should be sine of B, excuse me, not just B. So that should be our sine of B. And 765 is equal to the sine of B. And then we find the inverse sine. Okay, so our sine of -1 of 0.765 is going to be equal to B. All right. And so if we go into our calculator and just find the inverse sine of this number, 0.765, okay, making sure that we're in degree mode, we get 49.9. Okay, so B is equal to 49.9. Okay, now what we are going to do is we're going to see if a third possible triangle can arise from this. Okay, and here's how we do that. Okay, so, or I'm sorry, a second possible triangle. Right. Now we know that, okay, if we have, and this is degrees, by the way. Okay, so that's an angle. And so we know that for this triangle, okay, so if I just divide this up into two triangles, if I could, okay, and we could certainly find the third side fairly easily, okay, we know that C is going to be 180 minus 35 minus 49.9 degrees, okay? And in our calculators, if we were just to crunch that out, okay, so 180 minus 39.9 minus, or 49.9 minus 35. All right, that's 95.1. Okay, so I'm going to call C equal 95.1 degrees. Okay, and then all we'd have to do is just find one more side, which we will in a moment. Okay, but is there a second triangle available? Okay, so let's see. So remember we found B right here. Well, B prime, I'm going to call it B prime, which is going to be a second angle, is going to be 180 minus 49.9 degrees. Okay, or in other words, B prime is going to be equal to 130.1 degrees. Okay, is there another possible C, which I can call C prime? Okay, because remember what we did was we found 180 minus 35 minus 49.9. Okay, let's see if C prime exists. And so C prime would be equal to 180 minus 35 degrees, which is the given A, minus 130.1 degrees. And in fact, it looks like that we are going to be able to find a second triangle from this, because if I go on my calculator and I do 180 minus 35 minus the new reference angle 131.1, I get a 14.9 degrees. Okay. So indeed, there are two possible triangles for this. Okay. If this number was negative, okay, so this is greater than 0 degrees. If this number was negative, then there wouldn't be any second triangle for this. Okay. All right. So that's how we can go through and see if there is indeed going to be a second possible triangle. All right. Now, all we have to do for both of these is find side C. Okay. So this is angle C. So and also, we already have side B and A. All right, so what we could do is we could say that side C is going to be divided by sine of 95.1 degrees. It's going to be equal to, let's just use side A because it's a little bit easier to work with. So that's going to be 12 and 35. So that's going to be 12 divided by sine of 35 degrees. Okay, not 350 degrees. That would be kind of tough. Okay. Now what I'm going to do is just multiply both sides by the sine of 95.1. So 12 sine 95.1 degrees divided by sine of 35 degrees. And so this would be our last side. Okay. And so in our calculators, once again, right, what I'm going to do, oh, sorry, that's going to be our, sorry, I forgot what it was already. It's 12 sine of 90, sine of 95.1, I think. Okay. And then sine of 35 degrees. Okay. So we get 20.83 or 20.84. Okay. So I'll just say 20.8. Okay. So that's one set of the 20.8. Okay. So that's going to be one set of the conditions. Okay. So notice we have angle A, B, and C. We have side A, side B, and side C. Okay. Now the other one arises when we're going to take and solve for side C over here. Okay. Side C is going to be much smaller. Okay. Let's use the same ratio. Okay. So we're going to have C over the sine, except now we're going to use 14.9. Okay. And then we could have side A, which is 12, and angle A, which is sine of 35. We multiply both sides by sine of 19.4 or 14.9 degrees divided by sine of 35 degrees. And we could just shove this in our calculators. Okay. The good news is we already have 12 and sine of 35. So 12 sine of 35, we just need to change to 14.9. Okay. So that's actually pretty nice. It's going to be 14.9, and we get 5.37 or 5.4. Okay, so this one is going to be 5.4. All right, so those are our two triangles. Okay, so again, what you want to do is you just want to find a reference angle for whatever angle that you found initially. If that angle and the given angle add up to something that's less than 180, okay, then what happens is you're going to have a second triangle. Okay, so a second example of this, we have A is 40 degrees, A is 54, and B is 62. All right, so let's start by finding angle B once again. Okay, so we're going to have sine of 40 degrees divided by 54 is going to be equal to the sine of B divided by 62. I can multiply both sides by 62. So 62 sine of 40 divided by 54 is equal to the sine of B. And then I could just find the arc sine of this. Okay, so it might be a little bit easier for us, or you could just approximate it. So sine of 62 times sine of 40 degrees divided by 54 is equal to B. And so in our calculator, let's just figure what that out. That's going to be. All right, so I'm just going to take the arc sine of, we said 62 sine of 40. So this is going to be 62 sine of 40 divided by, it was 54. Okay. All right. Now we get degrees 47.5 or 47.6 when around to one decimal place. Okay, so that's going to be 47.6 is equal to B. Now, is there a second triangle? Okay, so we know that our B prime could be equal to 180 minus 47.6 degrees, okay? Or B prime might be equal to 132.4 degrees, okay? If a second angle exists, okay? To get C prime, that's going to be 180 minus 132.4 minus 40. And if that number is bigger than 0, then a second triangle does exist. Okay, so in our calculators, we take 180 minus 132.4. Okay, so this is going to be 180 minus 132.4 minus 40, and we get 7.6 degrees. Okay, so C prime is going to be 7.6 degrees, which means that there does exist another triangle. Okay, now over here we can find C rather easily by taking 180 minus 40 minus 47.6 degrees. Okay, and if we do that, so 180 minus 40, and what do we have? 47.6. Okay, that one's going to be 92.4. Okay, so original C is 92.4 degrees. Okay, so now for both of these, all we need is side C. Okay, it doesn't matter which one we tackle first. Okay, because once we have one, then we just have to change one number for the other. Side C, I'm just going to say C divided by the sine of 92.4 degrees is going to be equal to, let's just use the ratio of A to A, 54 sine 40. Okay, so it's going to be side 54 sine of 40 degrees. C is going to be 54 sine of 92.4 degrees divided by sine of 40. Okay, so just multiply both sides by that sine of 92.5. And then in our calculator, we have 54 sine of 92.4 divided by sine of 40. Okay, making sure we're in degree mode. 83.9 is going to be side C. So we said 83.9. All right, and that makes sense because it's the biggest of the three angles. Okay, so 83.9 should be bigger than these two, which it is. Okay, now to find C prime or side C prime, okay, I'm just going to call it C prime divided by sine of 7.6 is going to be equal to, we could use the exact same ratio of A to A. So it's going to be 54 over sine of 40. That means that side C prime is going to be equal to 54 times sine of 7.6 degrees. Okay. And then we're going to divide that by sine of 40 degrees. All right. So I'm just going to replace 92.4 with 7.6 in my calculator. Make that really easy for us. Okay. So just change this to 7.6. And that's going to give us 11.1. So C prime is 11.1. Now that should be the smallest, okay? Because remember, this is the smallest angle, okay? So 11.1 should be smaller than the other two angles or the other two sides. It's actually significantly smaller, which makes sense because our other two angles are significantly bigger than 72 or 7.6 degrees, okay? So that's the ambiguous case, okay? So make sure that to find that second triangle, you subtract from 180, okay? And then from there, what you want to do is whenever you find that first angle, just make sure that whatever your given angle is, if that angle and the angle that you found from the reference angle, if those are going, if you take 180 minus the given minus the reference, and that's still bigger than 0, that means that a second triangle exists. Okay, so that's everything for the law of sines. In the next section, we're going to start taking a look at the law of cosines.